Well, welcome to lesson 3. Really glad that we've made it this far. Um, I just wanted to take a minute here and cover a couple of housekeeping items. The first thing is that we're coming up in the next, not this week, but next week, the group projects will open up. And how that's going to work is you'll be auto-assigned to a group. Through Canvas, and there'll be 3 or 4 people to a group, and then that group assignment information will also open up so that you can see what that's all about. And it's basically there'll be like 2 or 3 different prompts that you'll have that you can be able to use, and there'll be a set of data that you'll be able to use in order to put together a short presentation as if you were either presenting to clients or to stakeholders. And you'll be able to leverage some of the things we've been learning in this class and things that we've been learning in the book. So that's the first thing. So just keep that in mind. It's coming up, and be ready for that. The second thing is that I've been looking at the modules, and after preparing for this lesson actually, and also reading a lot of your introductory letters, it seems like there is quite a bit of interest in the SQL part of things. The data part and the visualization part, people either feel like they kind of have down, it seems like, or at least are getting a lot out of the book. And to be honest with you, Cole does an amazing job between her book and her blog, and you can also find many of her talks on YouTube. I probably can't teach you a whole lot more than that. I'm happy to cover things in office hours if you have specific questions on how to create a particular kind of, visualization or something like that. But I've just been thinking about this and thinking about, best use of time here. And so I'm going to open a poll up this week. So watch for that. And the poll is basically going to be, after watching this lesson, do you want me to keep going on SQL? Or do you feel good about SQL between the tutorial and this lesson, and you'd rather have me talk about visualization more? I'm kind of leaning towards spending more time doing working, like going over SQL and different tips and tricks for SQL, and also some beginner stuff on SQL. And this lesson today is talking about basics. So in some ways it might feel like a repeat. If you've already finished the tutorial, you might be like, I've already read this. Why am I going to this lesson? Totally get it. You don't have to stick around the whole thing if you don't want to, if you've already got that covered. But I will cover some things that, in some ways, on how these different parts of SQL apply to localization data. And next week, what I'm thinking of doing, instead of covering data visualization, what I'm thinking about doing is covering, in depth, using some of these concepts of SQL with some like fake localization data that I've generated. So if you'd rather do that, just vote in the poll and let me know. But I'm kind of leaning towards that based on most everybody's writing so far. So anyway, that's the housekeeping business. So let's kind of get to it. All right. So today, like I said, we're going over SQL. And just to give you a kind of crash course, if you haven't already got it, of what this is all about, some terminology and some things about databases. So if we talk about the structure of data, you have what is normally referred to as the database, and it's made up of multiple parts. And those parts can include namespaces in some databases, and that's like a kind of subgroup of the database, or it can just include tables. A database might have many tables. So for example, MySQL doesn't really have namespaces. It's mostly just tables within inside of a database. But something like Presto or Hive will have a namespace, which is a particular section that might have different quotas or different measurements or settings than a different namespace, and then there'll be tables within that namespace. And the reason why this is important is when you're querying within a single namespace, you generally can't touch things in other namespaces unless you do something that like imports that data in order for you to use it inside your own namespace. And then the tables are basically what you might think of as an Excel spreadsheet, right? They're a set of rows or records and columns or fields, and then the values that are in the intersection of those two pieces. And so when we're querying these, that's generally what we're doing, is we're trying to get information out of the table within these. Now, when it comes to actually managing these databases, we like to think of SQL, and I think it'll help you if you were like me, as someone who's like, I'm not a programmer, like way back when, before I actually did some programming, I'm a language guy. I'm not really a math guy. I'm a language guy. If you think that way about yourself, it'll help you to think about, math in general, but also SQL as a language. So it is a language, and within SQL there's kind of 4 languages. They have different pieces to them, and they have different grammar. So they're normally referred to as different languages. And then within those languages, there's dialects, right? So the 4 different languages we're talking about are data definition. So these are like defining what data is in the database or the table, right? So select, insert, update, delete. We're managing data that's actually sitting in a table within a namespace or a database. And there's data manipulation, right? So this is like the handling of tables and namespaces and that sort of thing. So create a table, alter a table, truncate, or drop a table. So that's a data manipulation language. And then there's the data control language, which is granting permission, revoking permissions, things like that. And there's transaction control, which has to do with how that data gets inserted or how it gets synced and it involves like commits, rollbacks, and save points. In this course, we're only talking about DDL. We're only talking about data definition. And that's because as a data professional in localization, the most important thing is for you to be able to speak this language, the language of data definition. How do I talk to a database, a table, and get it to speak back to me and tell me the information that I need? Now, you may need, depending on the size of the organization you work in, depending on what you're doing, maybe you're a local engineer, or depending on what your interest is, you might need these other 3 locales, or basically locales, these other 3 languages, right? You might need to be able to understand the create, alter, truncate, drop type thing. But the most important thing is for you to understand the DDL part. So that's why in the tutorial from W3 Schools, if you read the assignment for that tutorial, to complete that tutorial, I'm not requiring you to complete the part on data manipulation about creating and dropping tables. It's only this part, the select, insert, update, delete, the where statements, all those parts. That's the important part. So when we talk about I needed to click again. Anyway, and when we talk about, I guess let me just move myself off of here so you can see all of these. So when we talk about dialects, what we're basically talking about is the different kinds of databases, right? So they're all SQL, most of them, but in some form, these are all SQL databases in some fashion, and they all just have different. There's certain functions they all share, like maybe select or something like that. But within those functions, there are different parameters that might be required or might be optional, or options you could choose within them. And also within some of these, there are some different functions altogether. There's things you can do in Presto that you can't do in MySQL. In fact, I'd used MySQL for a long time, and I never know how to pronounce it, PostgreSQL. I'd used that a lot in my life before I joined Facebook, but Facebook uses mostly Presto and Hive. Well, they've transitioned to Spark now, but those are the things that they mostly use, and so I don't use MySQL and PostgreSQL as much as I used to. And there's things that Presto can do that MySQL can't do that are pretty amazing. Some functions that are really nifty, and as I've been preparing for this course, I've been focusing on MySQL and just straight up like SQL, like SQL Server type SQL, to try not to focus too much on the Facebook aspect of things. And I've realized that a lot of the things I take for granted in Presto aren't the same in every other environment. So it's good to know that even though you might understand SQL, you have to get really familiar with the documentation, right? So there's always documentation for any of these given different database types, and you should have that bookmarked, and you should look through that constantly, and you should be referring to it constantly, and make yourself a cheat sheet or download a cheat sheet so you have the special things about that particular database. Now, the other thing to note is that even within a given SQL language or dialect, there are subdialects. So MySQL, for instance, if you use MySQL 5.7, there's things you can't do either at all or as easily as you can in MySQL 8, right? So versions also matter. And one of the things I found with Presto that's annoying is if I just Google certain things about Presto to get their documentation to pop up, it might not pull it from the most recent version. So knowing how to search the most recent version of the SQL that you're using, and having that bookmarked so that you are looking at the most recent one is will save you a lot of headaches, because you might bump your head into something and be like, oh, this query isn't working. And it turns out it's because you're using an outdated or possibly a too new of function or grammatic formula. So let's just kind of jump in here a little bit. Let's jump back to, I'll put myself back on the screen, I think. Okay. So this is, when you talk about coding, one of the things that they always talk about is like hello world. So hello world, if you've never done any coding before, is like when you write your first bit of code that ends up printing the statement hello world on the command line or on the screen or something like that. So what we want to talk about is the hello world of SQL. So like, how do I get a response from SQL? So right here we have a table. It just looks like, an Excel document. And it has, rows and columns, and you got a row for, user ID, or sorry, column for user ID, a column for first name, column for last name. And I want to find, let's say I want to find who are all the users with the last name Doe, for example, right? So this is the basic grammar of almost any select statement. And there's certain parts of this that are required. You can never not have it, basically. And there's other parts that are optional. And you can build on this and go from here, go crazy nuts, right? So basically, you always start with a select statement. So this is like your, subject, verb, object in a given language. So your oh gosh, my brain is blanking. Your syntax is select first, right? And then from, and then your other operations, right? So you have select, and then you have a field. You like what fields or which columns you want to pull data from. So which columns am I selecting? You can apply functions to those columns in order to manipulate them in some way, but you're selecting that data, right? Then you have to tell it where you're getting it from. And that's where you state your table. Now, in most places, you don't have to state the database. It's inherent in how you're doing your query, but sometimes you have to do that too in some SQL dialects. And just so you know, no one really talks about SQL dialects. That's just a made-up thing for this course. So don't go talk to your coding friends and be like, "Oh yeah, I can speak this SQL." No one talks about it like that. So I'm just using a paradigm to try to help those of us who may be language professionals first and getting into coding as a secondary kind of specialization to kind of connect your brainwaves to that. But it's not really a thing that people talk about. They might talk about a SQL language, but no one uses dialects or locales. Anyway, so then after the from part, there could be a number of operations that you might want to perform. So one of the most common ones is called the where clause. And I sometimes get statement and clause mixed up. There is a proper way to call one a statement, one call a clause. But anyway, the where clause is going to be like your filter, right? Where you can state only get the stuff in those columns from this table where condition 1 is true and condition 2 is true, or condition, so this is where you kind of set your filters and your logic. So that's the basic grammar of a select statement. So going back to our question, how do I find all the users with the last name Doe? Well, if I want to find all of the parts of the records, I'm probably going to select all of the columns from the table, let's call this table users, where last name equals Doe. That would be the easiest way to do that, right? So let's look at that. Oh, sorry. There's one other part here I forgot to mention. Another operation is you can group by. So if I want to aggregate data, like I want to find all of the, count how many users have the same last name, I could group by field last name, for example. And then I can order the results by a certain field or multiple fields in ascending or descending order. So like I was saying, the easiest way to get that data to talk to us that we were just looking at is to select. Now asterisk acts like all, right? I could actually put every column name in there, but I'm just going to say select asterisk. It's going to give me all of the columns, right? From database called users where last name equals Doe. So I actually have queued up, there's a cool tool if you want to check it out called db-fiddle.com. All right. And I've put a link here in a second. It'll be on the page to this bit of data that I've created. Now, on the left, you can see I'm using that data manipulation language where I'm creating tables, these fake tables, I have a users table here, and I'm creating some fake data, right? I'm inserting values into those different columns and creating rows, creating records, right? So I'm using that DML, the data manipulation language. And then on the left, I can, query the SQL. So for example, let's talk about that one we were just talking about. We want to find records where all the users equal dough. So I'm just going to put in select and then asterisk. And there is some formatting. You don't actually, most times formatting doesn't matter, but sometimes it does. But anyway, I'm just for now going to do some basic formatting. Also, capitalization doesn't always matter either, but sometimes it does. From a table called users, and we're going to say where last name, and it is case sensitive when I'm talking about a column, and I have a column called first name, last name, and then equals, and then I'm going to say dough, right? And then I'm going to run my query. Boom. It's just giving me a list of all of the users with the last name that equals dough. Pretty sweet. All right, let's go back. All right, so that's your hello world statement. And this is what it should look like, or if we're in DB Fiddle, it'll look like this. All right. So like I said, I'm going to share my DB Fiddle with you so you guys can also query this if you want to. If you wouldn't mind, please don't update it because I've kind of made it proper here. You can fork it. So just a little bit about DB Fiddle. If you click update after you made some changes here on the left side or the right side, it's going to update this to be exactly like you did it, and it could break it for other people. So I'd prefer if you don't, but anyway. And then fork is if you want to make your own version of this. So it'll basically like create a new ID for this, and it'll fork it for you. All right. Let's see here. Now, something about data types. So let's see. Let's go back to DB Fiddle. It'll help us understand this a little bit. So when I created my first table here, shipping, I stated what kind of data would be in each of these columns. So for the first one, I said it's going to be a big int. And for the second one, I said it's going to be a variable character, varchar, sometimes also char, and in some dialects, it's called string. And then in some dialects, you have to state how many characters are allowed in that particular one. And it has 12 right now. I could put 255, and then it would basically be unlimited, et cetera, et cetera. So, for example, the reason why this is important is, let's say I have a zip code, and my zip code is only able to take 5 characters because that's the way zip codes work. Then if I put 5 there, if someone tries to add or store a record that has more than 5, it will end up failing and saying, I can't do that, it's too long, right? And then you have integer, etc. So that's how every column has a type. The other thing is that different functions work on different types. So for example, I cannot add a string and an integer. Like if I want to do a sum function, for example. If I want to do a count function, I can count as many as I want. If I want to do an uppercase all, like uppercase all of the letters in it, I can't do that to a string. If I want to check the difference between 2 different dates, I can't do that between a character string and a date. So it's important to know that. Here are just some basic ones, and sometimes these are different in different SQL dialects. So a varchar, a string, contains text. Contains free text. Integer is a medium-sized integer, and then you have big int, which is a large integer. So if you have like many digits, you're going to want to use big int. Integer has some limitations. It's really meant for only smaller size numbers. Then you have a double, and this is like a double precision decimal number. It means it contains 64 bits, right? And then real is a single point precision decimal number, which means it can have up to 32 bits total in the total number. If you don't really understand what that means, it's okay. Just know that some numbers are reals and some numbers are doubles. You also have decimals in MySQL, and decimals are basically you can state exactly how many decimal points are allowed. Like how many total numbers before the decimal are allowed and how many after, right? And real and double just kind of have some of that baked in. And then some data types have what's called float, and it can be both. It can be either a 64-bit or a 32-bit. It can be a mixture, right? A Boolean or a bool is a true false, and sometimes these are stored as true false, and sometimes they're stored as zeros and ones. And then date is a formatted string expression. It's particularly formatted that expresses a date, and it normally has a certain format. And some SQL languages only allow you to use a single kind of date format. Others will allow you to specify it on the column. But it is just the date, doesn't include the time or anything. Then you have the date time, which is the date and the timestamp, and can also include the time zone and that sort of thing. And then timestamp is just a time, right? So it's not going to include a date. It's just a time. So it's different than date time. An array is a list, normally a comma separated or other separated list of things. It's not a string. Each thing inside that array is its own object or own entry, right? So you can have an array of strings. You can have an array of integers. You could have a mixed array that has many different data types in it. But arrays are good because they're indexed, so they have an order, right? So I could call the third item in an array and call it back in my query. Or I could ask my query to tell me what is the third item of a given array. So we won't get into that very much, but just know that that's a data type that's out there as well. All right, so this is the link to my fiddle that I told you about. Again, would prefer you not to click the update button. If you do, I'll redo this. I haven't bothered to sign up for a pro edition that would allow me to save this so you guys can't touch it. So please just be careful and kind. All right. We're going to go through some functions here, and that's what I wanted to really talk about today, because some of these functions might be confusing to you. Some of them you might get confused with how they work in Excel, and what I'm going to try to do here is talk about how they might be used, not with localization this week. Hopefully that's next week if everybody agrees with that shift. But I'm going to talk to you about how they relate more to Excel, right? Some of them are obvious like sum, but some of them are less obvious like coalesce and try, right? And so I'm going to help you try to understand, for those of you who've used Excel, like how this transfers over. And at first I can tell you it's going to feel like, why would I not just use Excel? And I'll be honest with you, there are times you should just use Excel. It's going to be a lot easier to just use Excel. But there are other times, like if you need to do multiple VLOOKUPs or multiple if statements, where you definitely should be using SQL if you can. All right, so we're going to talk through these a little bit, and I'll show you exactly how they work. Okay, so the first is a sum. Okay, this is the most basic. It's not going to let me do that, huh? Okay, so I need to actually, I was hoping I could select stuff. So I'm actually going to have to do it this way where I have this open. So hopefully you can still see this well. Okay, I'll just maximize this so I get as much as possible, and we'll look here. Okay, so this is a basic sum statement. So in this case, what we're looking at is a shipping table, right? Now let me just show you what that shipping table looks like, so that for the rest of the time we talk about this, you know what it looks like. So shipping from, select all from shipping, and then run it. And you'll see what our table looks like. So it has users, the origin of the shipment that was made, the origin zip code, the number of packages, and the total cost. So that's our basic shipment data. So if we go back to our sum example, what we're looking at is we're wanting to find out what is the total number of packages sent from a certain state. What is the total cost or revenue, maybe if you're a shipper, that state is generating? And what's the average cost per package per shape? So although this is average, right now we're not using the average function. We're using the sum function and doing some math, dividing one sum by the other, okay? So let's go ahead and take that and let's go back to our fiddle. And let's throw it into our fiddle here. And then let's click run. All right, so now we get California, New Jersey, Hawaii, Colorado, North Dakota, Alaska. So the total amount of packages sent from California was 30, right? And the total cost or revenue that state generated for this company was $327. And the average cost per package was just under $11, right? So the one with the highest revenue actually is Colorado with 237 packages, but their cost per package is lower. So anyway, this is an example where we can use sum, and there's a couple things I want to call out here. When you, when you are looking at doing a sum, you have to aggregate it, right? And what that means is you have to group it on something. You can't just say sum on each individual one. You actually need to say sum it, but aggregate it to what? You want to know the sum of all packages where? Per user ID, per state, per zip code. So you need to say what you're grouping it by. So in this case, we want to know per state, what is the total state packages, total state costs. If I don't have this, my query will fail. It'll say you can't do sum without a group. So you need to have at least one in the group. If I actually also add the second one, total state packages, into the group by, it'll also fail, saying, hey, you can't like group on something that you're grouping. Like that's not allowed. Sorry, bud. And so you have to make sure that you're grouping the things that you want to group by and aggregating the things you want to aggregate, right? So just something to call out there. Another thing you might notice here is this as thing, and it's a little bit clearer when you look here because the linting or the visual rules that they have in here help kind of show that. This as thing is just for me, right? If I don't put as in here, this column will either just be called column 1, column 2, column 3, something like that. Or it might sometimes have the text of this function in it. It might say some packages so that I know what it is. But if I want to call it by something and have a name that means something, I can do as and then some text. It has to be a single word and it can't start with a capital letter or a number in most languages. And the thing about that is that these are called aliases. So I've now created an alias for this aggregate that we've done, right? I can also use aliases on the tables themselves. So if I create a table that has a really long name and I just want to call it S, I can do as S like that. And now this, every time I want to refer to S in the future, I can just type S. So aliases are super handy. So group by and aliases are one of the things we picked up in this sum example. All right, let's go to the next one. Where are we at anyway? I'm colorblind, and so I have a hard time seeing where we're at. Okay, there we go. All right, average. So before we did an average by just doing the math, but you can actually use a function just like in Excel for an average, right? So sorry, I'll go back real quick. When we talk about group by, it's kind of like a pivot table, right? So in Excel, if you think about Excel, you have a pivot table. That's what it's kind of like. Like you can perform math on numbers in a given field. So for example, like I could say, let's do some sum. We don't have to use group by for sum. Let's use an example where we want to say what is the average cost per package. So for example here, that doesn't have to be a group by. Let's say that's all we wanted to know was for each of these different shipments, what was the average cost per package. So let's go ahead and run that. Oh, it didn't like that, sorry. Sorry, one sec. Yeah, UID, there we go. Oh, yeah. So you do have to use sum with that. Sorry, my bad. What I meant to say was that you don't have to aggregate to do math. This is like where you make a fool of yourself and you're like talking. And anyway, so you do have to use aggregate for sum. Like you have to use group by for sum. But if you just wanted to do some math, you don't have to use group by. See, now I'm just doing some simple math to find out the average cost per package. And that's on a per record basis. So I'm not grouping it by anything. I'm just finding out the average cost per package on a per order basis, right? Not for everybody, or not for the whole state, not for the whole zip code, not for each user, just plain old per order. How much did they spend? All right, and we'll come back to that. Okay, so average on the other hand, let's say we wanted to find out what per state was the average number of packages that they sent, right? Or the per order. Let's go ahead and throw that in there and see what we get. So in this case, I'm going to go ahead and take myself out again. I think you guys probably want to see the presentation more than me. In this case, what you have here is we're grouping by the origin state. So we're trying to know by state, what is the average package count and what is the average total cost. So we take for all of the packages in each state, what is the average? That gives us our average package count. What is our, in each state, what is our average total cost? right? Now let's say I wanted to group it by something else. Let's say I wanted to do it by UID. So per person that actually put in an order, what was our average number of packages that they shipped? Let me show you another thing that we'll come across later. So it's throwing an error because it's saying, hey, you're not grouping by anything. And that's because you can't group by something you're not selecting, right? Now, some languages you can. Some languages you can do that, but not in this language. So I either have to change this to UID, or to make my query super generic, I can say number 1. And so you can refer to these columns either by their name or by the number of them. So this is column 1. This is column 2. This is column 3. So I say group by 1. Now we should see one that shows us the average per user ID. There we go. Nice work. So that tells us what, if we wanted to find out, like, what is the average person spending, right? Okay, so let's go back here. I think that's it for that one. Okay, count. This is a great one. There's 2 ways to count, and we'll talk about that in a second. So in this case, we're going to talk about, let's find out how many users in our shipping user database are active. How many of them are actually active in our system and haven't been removed or deactivated. So over here on the left-hand side, I have 3 databases in here. I have one called shipping, one called users, and one called source locales, 4, sorry, and one called target locales, which we'll get to in a little bit later. But right now we're querying the user database. And that database has the column UID, first name, last name, and active, which is a true or false. Are they active or are they not? So what we want to find out is how many users in the system are active and how many are not. So we are grouping by their active status, right? We're not grouping by the user or by their name. We're grouping by active status. And then we're going to count the number of UIDs that are in that one, right? So for example, another thing we can do, I was going to mention here, is let's run this first, and then we'll talk about using that where. So when I run this, I find out that I have 4 active. So I mentioned that sometimes Booleans can be 1s and 0s. I have 4 active users and 2 inactive users, right? Now, I can also combine this with and notice these slash with asterisks, that's how you comment something out. And you open a comment like that, and you close a comment like that. Oh, except for you want to use the right ones, like that. So now this whole line's commented out. Some languages it's simpler, and you can just put dash dash or hash at the beginning of the line, and it will comment it out. Yeah. Okay, so now this case, it's going to count all of the active users in each status and inactive users in each status where their first name isn't null. So some of these users have a blank first name for some reason, right? So I want to find out a list of all of the active and inactive users and the count of all the inactive active users where their first name is not blank. It's not null. And there's this slight difference between blank and null. We'll talk about that in a second. Actually, we'll talk about it now. Blank would be the entry is actually nothing, but it exists. Or, it's nothing, but it exists, right? As opposed to being null means it doesn't exist. So the difference here, it would look like this in the code. It would just be like nothing in between these 2 quote marks. But if I put null, that means there is no entry for that column, okay? So it's slightly different than is blank. If I wanted to say, like, find it where they're blank, I would say equals like that, right? And that's different. But you could do where first name is null, or if both of those happen, first name equals blank, and it would find either one of them, right? But in this case, we're just going to do null because there is no blanks. All right, let's go ahead and run it and see what we get. All right, so now we only find one active user because it is null. I think I changed it from not null. And that active user is, or that user is inactive. So the only user of all of our users that has a blank name is blank, or a null name is null McSimmons. And he is, she, them is false. They are not active. Now, if I change this to is not null and we run it, you'll see a different result. We have 4 active users that don't have a null name, and 1 inactive user that doesn't have a null name. There's 2 inactive users, but one of them has a null name, and so that's how we use that filter. All right, let's go back to our thing here. Okay, count distinct. All right, so this is a little bit different. So let's see what happens when we count the number of origin states in our shipping database. Okay. If we just want to count how many states have been filed, it says there's 8, right? 8 states. And so if I just show you the data here real quick so you can kind of get an idea of what we're looking at, that's this data right here. And it's saying across all of these, there are 8 states. But hang on, there's not 8 unique states. So what if I want to know out of my whole database how many unique states there are? I can add the word distinct. And when I run that, you're going to see we get a different result. We only have 6 because California is in there 3 times, right? And so if I'm trying to find out, get a distinct list, like remove duplicates, basically, if you're thinking about Excel, I would use distinct when I count. You could also sum distinct. You can use distinct in a lot of places. You can select distinct if you want to get just as distinct values, for instance. So there's lots of different places where distinct can be used, but it basically makes it so that you can take them out. Now, there are places where you want both, right? If you go back to our example before where we tried to find out how many users, if we'd use distinct there, in some cases it might not be the data we want. We want to just count every single row where that is where the where statement is true. If we put in the distinct, however, we want to find every unique row or every unique record where that is true. So just something to keep in mind. The distinct is important. Okay. Next one. Not exactly cruising, but we're moving along. Cast. Okay, so remember we talked about data type up here a bit. I think it was up here where you have these different data types. There are times where you might want to change that data type. So this could happen for multiple reasons. You might have 2 databases that you want to mix together, which we'll talk about in a little bit. It's called a join. And the key of the column that you want to join against is a different data type. Like maybe one is a number and one is a string. And but you know that they share, they're related through those fields. You have to reconcile that. You can't just join a string to a character. Another time is where maybe you want to add some things together. You want to do a sum or you want to do some other mathematical operations. And one of the fields, for whatever reason, is a text string instead of a integer or a float or something like that. So that's another example where you might want to use that. And a lot of times I use this cast thing because my data is not great. And I don't have control over it most of the time when that's the case. So using cast is generally something like that. Another time where I'll do that is where we have something that's in a text string for a date and I need to get it into another format. I might want to cast it that way. I might also have to use some special date parameters, which I'll show you in a second. But yeah, that's kind of why we might use cast. So let's go back to 15 and talk about it. So this is an example where we might want to cast something. So for example, I want to cast this as a decimal and I don't want it to have like a billion things. I could round it, but my other option is to cast it as a decimal. So I'm going to try to get the sum of all the packages, sum of all the total costs, and then I'm going to cast the average that we calculated before. Remember we calculated the average cost per package. I'm going to cast it as a decimal with a maximum number of 30 digits and only 2 decimals, right? So let's go ahead and try it. So again, if we're going back to our grammar, just if you're feeling a little bit lost, our syntax, we're talking to the computer, we're saying select the origin state, the sum of all of the packages for that origin state and call it total state packages, the sum of all of the total costs for a given state and call it total state cost, and then give me the average so the sum of the total cost divided by the sum of the number of packages as a decimal and call it the average cost per package from the shipping table. Okay, so that's what we're doing right now. Let's go ahead and run it. All right, here we are. So notice in this column here, we have this really neat and tidy 2 decimal maximum number here, right? Super great. Instead of 12.33333333 or whatever it would have been, we just have 2 decimals. Now it's different than rounding because we're not exactly rounding. We're just cutting it off. Okay, so that's one of the differences between casting something as a decimal and rounding. All right, let's try something else. Let's say instead of a decimal, I want to cast this as a, I just don't need to cast it as a decimal. I'm going to cast it as a varchar. All right. I think I can do this. Testing me. I might just have to say car. Yeah, it didn't like that too much. So I think it just wanted its character. Yep, here we go. So notice here before, it cut it at 2 decimals. And in this case, when I did character, it just kind of printed it. And it defaulted to a certain number of characters as the max length. If I change this, I think I can specify the length I want and make it super long. It might get a really big number. Let's give it a shot. No, not in this case. I guess it just stops there. So anyway, there's something about this particular language that trims it to those first few numbers. So that's kind of how that one works. But if you notice, this is now a string. So if I tried to apply math to this in a later query, it would die because it's a string, not math. So you can't add like a word together. This is now the word 10.9000, not the number. Okay, so that's a little bit of the difference there. So that's a bit about cast, right? Okay, length. I don't think I'm going to show you this one. It's pretty much the same as Excel, but it tells you the length of a given record. So you might want to get the number of characters in a given field in a database, or you might want to double check data. So for example, one that I've used before is tell me the max length of a locale name. So if I know my locale names are only ever supposed to be a total of 5 characters, 2 for the language, underscore, 2 for the locale, and if it's ever more than 5, it's going to break my system. I could run a query saying, give me the max length of the locale field. And if I get a 6 or more, then some record's wrong, right? Or maybe I know that my record, that particular field is supposed to have 5 digits, like a zip code field. And I say, give me the max length. And the max length is, I don't know, whatever, 6 or 7. Or maybe I say, give me the min length, right? It will give me like a 3, and then I'll know that that record is broken, right? So I can find the ones that have that length. So length can be super useful. There's other ones too, like left and right, just like in Excel, where you can get just the left X most, like the left 3 or the left 4 most characters, or the right 4 most characters. So those are pretty similar. You can look those up, but they're very similar to Excel. Upper and lower are useful for dirty data. This will basically uppercase all of the characters in a field, or lowercase all of the characters in a given field. And you might ask, why would I want to do that? The biggest reason I would use this is when I'm trying to filter on that, and I'm trying to filter. So for example, let's go back to our data real quick and imagine a scenario where we're looking for all the people with the last name Doe, but Theolodicus happens to spell his name with a lowercase d for some reason, right? And so when I try to find Doe, and if I look for all of those who have the name Doe, and I search for like an exact match search, then I'll get Jane, but I won't get Theolodicus, right? So what I might do is first apply upper to the field last name, and then all of them would show up in my query as uppercase DOE, and then I wouldn't be, my query wouldn't be fooled by mistakes in the data, if that makes sense. You also might just want to transform your data. Maybe there's a shift and you want everybody's last name to be uppercase. You could perform that shift using upper. Okay, concat and aggregate. I can't remember if I show this. I don't think I do, but let me explain. Concat is when we combine multiple strings, and aggregate is when we make a list from multiple things. And the difference is the end result of an aggregation would be an array, right? We would make an array. So an array and a concatenated list are different because an array is a data type, right? And a concatenated list is just a string. So if I use a concatenated list, an example of that would be I have a first name and a last name field, and I want to concatenate it so that it's first name plus last name equals the full name, right? So if I wanted to concatenate first name, last name with a separator of a space, my result would be full name, right? So that's an example of where you would use concatenate. And then aggregation is when you want to get a list of all of the things in a given category. So for example, looking back at my data here, let's say I wanted to find out all of the states that a given user had shipped from, right? So for example, user 1005 had shipped from both Colorado and North Dakota. I could create a query that would tell me, give me an aggregated list of that, and it would be an array. And the difference is they would still be stored separately. They wouldn't be stored in a single field like if I did first name, last name put together. They would be stored separately, but they'd be stored in an array, and I could actually reference them later, right? Those individual pieces of data. So I guess it's kind of like making a table within a table, which isn't something you can do in Excel. It would be like taking this information and creating a table within a table of all of the places that a user had shipped from, right? The other way I could do it is tell me all of the users that have shipped from a certain place, right? And so then I would get a list of all of those users, but they're still intact as separate pieces of data. Whereas when I join two names together, I get a new string that is Joe Schmo or John Smith, right? So it's just slightly different than if I have an array. If you do any programming like Python or anything like that, it's like a dictionary, right? Where you have a set of data that is indexed, and each item in that list has a number that you can refer to it by, right? So the first item is 0, the second item is 1, etc. And so that's the purpose of storing that. So if you ever need to create an array and like get that data together, but want to reference it later, specific individual pieces, then an array is the right function for that. If you just want to jam pieces of data together into a single string, then concatenate is the right thing for that. If that's not super clear, go ahead and make a comment, send a message, and I can go over that more next time. Rounding is just like in Excel where you can clean up data. You can round using specific logic. You can round up, round down, round to a certain degree of accuracy, etc. Like when I say degree of accuracy, I mean a certain decimal point. Parsing dates. Now, we could spend a whole lesson on parsing dates. You should spend time looking at that. And that's because they're super tricky. And there's tons of really cool things that you can do with it. So let's just go here to the MySQL tutorial. Take a look at that. And let me just walk you through some of the coolness that's there. If you go there, down here under references, there are, I think it's MySQL functions. And then there's a whole lot of them, right? You have string functions, you have numeric functions, you have date functions, and this is all of these are date functions, right, on this side here. And they do all kinds of cool stuff. So like you can add date. So add a certain amount of hours, years, minutes, months to a date. Add time. So maybe you can't do time with date, but you see what I mean. You can get the current date. You can get the current time. You can get a current timestamp. You can just like call something a date and do some functions with date. You can get the difference between two dates. And then a really important one is date format. So definitely check out this one at the very least. And what date format does is you take a string like this one, and you say you want to transform it into another format, like year. So for example, let's say I have this one, and I want to transform it into a different format. I can specify year, month, day, which this one is. I could do year / month / day. I can do year space / day space month, all kinds of things, right? And then these parts here, this language here for these format indicators are down here. And they are similar but are different in each dialect of SQL, right? So like A is the abbreviated weekday name. So you could get that information from this. You could find out like the sun, sat, or whatever. You can get the abbreviated month name. You can get the numeric month name. All kinds of stuff, microseconds, milliseconds. You can get hour in 24-hour format or 12-hour format, all kinds of things. So this is a super important function because let's say you have two different data sets, and one of them uses one date format, and one of them uses another date format. using date format to reconcile those two is really important. Or let's say you want to have those dates displayed a certain way. You can do that exactly the way you want it using date format. Another thing, let's say you wanted to get just the year and the month. You can do that from here, right? There are other functions for getting just the year or just the month or just the month name, etc. if you want. Or the week of the year, for example, or the year week and things like that. You could convert it to a number of days and different things like that. So there's lots of things that you can do with this, but with date functions. But this one right here is a pretty standard one that I use all the time, or some function of that. And the result of this is a date string, not a string. It's a date string. Now you can go the other way where you have a date and you want to create a string from it, right? So like date to string. I don't know if MySQL has that, but there you could use convert or cast to get a string from a date. You could say cast a date as a string, and then that is no longer a date. It's then a string that you could use in a different way. So date format is good. String to date is pretty much similar to date format, but less options. You might need to just get the year of a given thing or the month, or like I said, date diff is great because you can take the first date and the second date and get the difference in many different units, hours, months, years, and things like that. Week of the year I use a lot too if I'm trying to track things by week. It helps me to like do a weekly chart instead of a monthly or a daily chart if I want to. So yeah, that's one that I'm not going to dig into detail here, but if you want me to in the next lesson, chime in and let me know. But spend some time there. And the other thing is, like I said, it's different for every language that you work in. Okay. Try and coalesce. These are super important. So one of the things that you will find that is super frustrating if you're working with someone else's data that you didn't make, or even data that you made that you weren't sure exactly how to do it, is if you have nulls or zeros in your data, right? So for example, if you try to operate on a column and it has nulls in it, SQL is going to throw a fit. It's going to say, I can't do that. I can't add something that has a null. So let's say instead of 0 in this particular table, I had a null. And I said, add all of them. It's going to say, I can't add nulls, right? So then you either have to take out the nulls by saying where null, right? Or you have to come up with another idea. Another thing here, let's say I want to get the total cost or the average cost, right? And I try to divide the total cost by 0. I'm not going to be able to do that, and I'm going to get an error in most systems saying division by 0. Sorry, not allowed. And so, like in that case, I want to have some sort of other option than that, right? The other option than an error that kills my entire query, right? The other thing is, if your data isn't always under your control and other people can add to your data, and even though your data works fine right now, later someone might add a record that has a 0 in it, you probably want to protect your query against that. So in this case, we would do something like this. So try, what it does is it tries an expression, funnily enough, and then it returns a null if it fails. So instead of throwing an error, it's like, oh, I tried it, didn't work out, return a null. Sorry, I've been talking for a while and didn't bring any water today. I normally bring a water when I'm recording. I'm going to go get some. Hold up. Okay, and we're back, and you didn't even realize I was gone. Okay. So this is kind of similar to, if you think about Excel, and you think about a lot of times you might have to do if error, or if, and do an if-then statement. And if this happens, then return this value. That's what this is like. So this is basically your if error. It's kind of your fail-safe against a problem. And then it returns a null. Now, let's take that even farther, right? So right now, if I run this particular part in my query, try total cost divided by packages as per package, then I would get these results, right? And what I would end up with is a null in the column for California, right? And the reason why I would get that is because it tried to divide by 0. And when it tried to do that, it said, nope, and it put in a null, right? So that's how that works. Let's take it a step further, though, because you might not want that null in your data. You might want a 0. Maybe nulls are no good because later you're going to add addition and then you're just going to run into this problem again. That's where coalesce comes in. So coalesce is basically, it returns the first non-null value in the list, right? So for example, in this list, I can have multiple things. I could have like item 1, item 2, et cetera, et cetera. Or I could have an expression 1, like a try expression, and item 2, et cetera. There's lots of things, and that's what I'm going to do down here. So by combining these two, I can actually do some cool things, right? So for example, we're going to try to divide by 0, right? And then if we get that, it's going to throw a null. But because coalesce goes down this list of things until it finds the first non-null value, it's going to put a 0 there, right? Instead of a null. So let's go back. When we did it this way, try helped us out by not killing our query, and instead it put a null in, right? But if we don't want a null and we want something else there, then we could do this, where we do coalesce with a try inside of it, and then my second item is a 0. So it tries to divide by 0, gets a null, then coalesce says, oh, I don't like nulls. It goes to the next one. We get a 0. And that's what ends up in our query results. Now, something important here. If I put, instead of a 0, something like no good, right? It's gonna break because I still have a data type, right? Where I am taking two integers and I'm dividing them by each other. And so my data type that is inherited from my expression here is integer. So then if I make my second argument here a string, coalesce is going to be like, yeah, that doesn't work. I can't replace what should have been an integer with a string. Nope, not going to do it. And it'll break it. So just know mixing data types rarely works. There are some specific cases where mixing data types can work, but in most cases you can't mix data types in a column or in an expression like this. So that's why we use the 0. Now you could do a try, and then you could perform an operation on a string, and if that operation broke, you could have a string as your coalesce. But you can't mix data types, I guess, is the main part here. So this is really helpful when you're working with data that is inconsistent or has holes in it, like the data that we looked at here where we have these nulls or zeros, and we're trying to do math against 0, or there's nulls in the data. Coalesce and try are your friends, and you should get super familiar with them. All right. Let me just, now that I think about it, I'm just going to go ahead and actually show you in the query, because maybe it's kind of hard to understand the way that I'm doing it right now. So you don't need to do coalesce and try. You don't need to have a group by statement. So unless you're doing a sum, right, then you would. But I'm not doing a sum. I'm just doing maths. Okay. So I'm going to do everything, and then I'm going to do this new thing that I was trying, right, where we try it, and we want to pull every single column, and then we're going to create a brand new column called per package, and we're going to try total cost divided by packages, and if that gets us a null, we're going to rely on a 0 as our value. Let's go ahead and see what happens. Oh, really? It didn't like that. There's no try in MySQL apparently. I'm going to just hop back to a version, see if this works. Give me 1 second here. Nope, no try. Interesting. So there you have it, folks. Try does not exist in MySQL apparently. We're just going to double check that with the good old Google here real quick. Need to put G in front of it, otherwise my system thinks I'm looking for that. Okay, yeah, so apparently there is no try for MySQL. So there you have it. Certain languages are better than others for certain things, and I don't know why I thought you could do that in MySQL. Presto, you can definitely do this, and it's a lifesaver in some of their SQLs. So keep it in mind. MySQL doesn't have it. I think with MySQL you have to do some fancier stuff. Gosh, I feel really silly. Sorry for confusing anyone, but it's still super important when you can use try. All right. max and min we talked about a second ago, but these are basically allows us, if we're aggregating a set of data, it finds the maximum value in that set of data and the minimum one. So it's not finding the first or the last, it's actually finding the maximum of that, right? So let's go ahead and take this here, go back to our query. And let's run it here. Let's go back up to 8 because I just don't like 5. All right. So in this case, what we've done is we found the max. So for California, for the state of California, the maximum cost that was spent by anybody was $155, right? And if we look here in our data, we can see clearly that that's the case with $155. The lowest amount spent in California in this set of data was 72. And the average maximum the maximum per package cost, so again, total cost divided by number of packages, was 14.4, right? Okay, so that's how we did that. We got a max. So you can do max of not just a column, but you can do actually max of things like maths or operations within a column. So that's important to remember. Okay, we're almost through here. Okay, case. I love case. Case is really great. So case is like an if-then statement, but you can do a lot of stuff. So you don't have to just do if-then, if-then, if-then. You can do if this, then that, if this, then that, if this, then that, and just keep on going with that instead of just if this, then that. So basically, I'm going to use case when I want to manipulate the data or do something with the data based on a set of conditions, right? And its grammar or its syntax is case, when, condition, then result, when, condition, then result, and then else is what happens for every other instance that doesn't meet one of these conditions, right? So basically, this is my first one where I say when the origin state is California, then put the string West Coast, right? And then I have another one. So basically it checks them in order. So it does them in the order that they happen. So it checks all the data and does this first, right? So then it checks all the data again and says when the origin state is in the list of Hawaii and Alaska, then put in the string extracontinental. And for everything else, put in the string somewhere in the middle. And then you have to end it. Notice there's no parentheses in cases. So it's not like other things where you have to put parentheses around the data. You just case end, right? And then I'm using an alias as to call this region. Let's check out what this looks like in our fiddle. All right, let's run it. Oh, I broke something. Let's see here. It says, check the manual for your version. The right syntax to use in your California. Aha. Is not correct. You need to use equal. Okay. So some SQL languages you can just say is for strings, but in this one you have to say equals. All right. Now it's saying near the middle. Okay. So what it's not liking here is that you see my quotes. PowerPoint corrected them to smart quotes, and in most languages you need straight quotes. So that was my problem. Okay, there we go. So now what it's done is it's gone through that list and it said California, and it's been given the region of West Coast. New Jersey, somewhere in the middle. Sorry for all the people from New Jersey. They're probably not happy about that. Guess we need to add a new one. Let's go ahead and do it right now. When origin state equals New Jersey, then East Coast. Now, you're probably thinking this is pretty silly. When would I ever do this? Because honestly, this is the worst way to do conditions because you'd have to do 50 of them, right? You're right. It'd be a bad way to do conditions. But I'm just, for the sake of argument of how we might use case, this is an example. And I'll show you a better one when we do localization data next time, hopefully. All right, let's rerun that, and hopefully we'll fix New Jersey. Okay, so we have West Coast for California, East Coast for New Jersey, Hawaii is extracontinental, Colorado, North Dakota, somewhere in the middle, and Alaska is extracontinental as well. I suppose it probably should be extra contiguous because it actually is on the same continent. Anyway, yeah, that's true. Hawaii is the only extracontinental. Anyway, we're splitting hairs. The point here is that you can like look at the data and based on a set of conditions, do something else. Now, another example here would let's say we were looking at our shipping data, right? And we were saying, okay, when the amount spent, the total cost is above 100, then put in a high, medium. We can do high, medium, and low, right? So this is actually pretty common. So let's say we're going to do all. We're going to select all from the shipping, and then we're going to do cost range is going to be the name of our column, and then we're going to change all of this logic, and we're going to say when the total cost is greater than, let's just say, I don't know, 200, okay, then put in a high, and then we'll do when total cost is greater than, so remember it does the first one first. Now we want to go to our next one. We'll say greater than 100, then medium cost, and then when total cost is greater than let's say 10, then low, else insignificant. Oh man, I think I spelt that wrong. Yeah, I think that's something like that. Okay, so like let's say that's what we had some sort of like a scale or something that we had at our office, and we wanted to like categorize them, right? Run. Oh, so this is an example of when you don't need group by and you put group by in, it says, what are you thinking? So because I'm not doing any sums or anything like that, I don't need a group by. Boom. Okay, so now I have all of these records of when user 1001 shipped from California and they shipped 25 packages, total cost of 100. Then I say low, right? That's not right though. Okay, what happened? Aha, we didn't, Corey did not think through this. So this is an example where you have to think through your data, right? Why did this happen? If we go down our logic, 100 is not greater than 200. 100 is not greater than 100, but 100 is greater than 10. And so it marked it as low. So now we realize that we actually should be using greater than or equal to, right? Or we need to be more inclusive in the way that we do our statements there. So if we rerun this, we should get some new, medium. So now this one that had 100 is medium, one with 72 is low, one with 490, low. We have no insignificant entries. Great. All right, so then once you have that, you could actually start to look at how many low versus how many mediums do we have, right? We could start finding that out. And then if we had date records next to this, you could start to trying to see like what is our pattern for medium and low shipments, for example. All right, which we might even get into this next part here. Okay, so this is another example, right? Let's just throw this in here as another example of case from users. So let's say we're trying to validate whether a user is real or not. And we found some things about users. Okay, so I think we got a problem with our there we go, straight quotes. There we go. So yeah, like I said, PowerPoint and Microsoft Word in general like to correct your straight quotes to smart quotes. So that was my problem there. Okay, so in this case, what I'm saying is select the user IDs, and then if the first name is like J, and then there's this, so this is a cool operator called like. So it's like a fuzzy search or regex, but not quite. And then this percent is basically a wildcard. So if the first name starts with J is basically what this means. If the first name starts with J and the last name equals Doe, then mark it as a fake user. When the first name is null and active is false, then mark corrupt user. And then otherwise mark it as null and put that as validation, right? So if we run this, these users are fine. They don't have a validation. These users are corrupt because it's a John Doe. I can't remember who it is here. Yeah. Jane Doe is active and is not a real person because someone called themselves Jane Doe. Now, maybe there is someone called Jane Doe out there. That's probably not fair. And then 1004 so that's a fake user. 1003 has no first name and they're false. Something's wrong here. Everybody should have a first name. Corrupt user. Burnt. You could also do something else like else acceptable or something like that, or pass or something like that. And that way, instead of having a null on their record, they would have this in there instead. All right, so that's cases. Super useful. You can do embedded cases too, which is kind of crazy, but I use these a lot when, let's say I'm trying to categorize data. So one place where I've used this a lot is when I have a group of requesters that belong to different departments. And those departments are loosely maybe similar. And so maybe I want to like say, if requester is from this department, then mark them as a marketing category or marketing client. If requester is from this department, mark them as a technical, that kind of thing. So I use it sometimes to create categorization that might not already exist in the system. The downfall of case is that you might not know every single case that could exist. So this, whatever goes in the else, could totally mess things up. So just think about that. Make sure you think about that. Now, you don't have to just use this with text. You can also use it with numbers and math. So you can think through that too. Like if the number is between this and that, then perform this mathematical operation. If it's between this and that, then perform that mathematical operation. Also, you don't even have to use the same field. So like, let's say if first name equals is like this, then do something to a different field, right? Like change their last name to X or something like that. So there's different things that you can do there, right? Okay, where. We've talked a little bit about where, but let's just go into a little bit more, right? So where is the filter of SQL, all right? And it can also use functions in it. So you can do things like or is greater than, or things like that, is not, right? You cannot reference an alias. So we talked about aliases a little bit here. So if I have something like this as validation, I can't use the validation column in my where statement because it doesn't exist yet until my query runs. I have to use one of the ones that's already in my table. The other thing is that you can't do aggregations. So you can't do where sum of all of these things is greater than that. You can't do that. It doesn't like aggregates in your where statements in most languages. There's also something else called window functions. You can kind of do something like that, but we're not going to go into that. It's pretty advanced stuff. But where is the filter of SQL? This is how you filter columns like you would in Excel. One of the things to be aware of though is if you reference something in your where statement, you possibly can create a filter you didn't want. So like if you say where equals this, it'll try to match that. And if that column doesn't exist, which could happen due to joins, which we'll talk about later, then you might inherently be limiting your data unknowingly to a set of records where that column does exist, right? If you're trying to read that column in your where statement. I wouldn't worry too much about that, but like sometimes if you're getting results that you don't expect, always double check your where statement. All right, second to lastly, this is a long lesson. Hopefully we can get it done in under an hour and a half. Joins, all right? Joins. Second most important thing maybe to learn about. They're confusing. Joins are super confusing, but they're super important and you're gonna use them all the time. So the idea of a join is if I wanna do more than just look at one table, I wanna look at two related tables, I need to join them together in some way, right? And I need to have a key or something I can join them on that they relate to, right? And there are multiple different kinds of joins, but we're going to talk about 4, and that's the left join and right join and the full join. And these 3 joins are outer joins. And then finally you have an inner join, right? So you don't have to type like left outer join, but it is an outer join. Why? Because you're getting records outside of this overlap area, right? You're getting records, in this case, the outside of the overlap area. And in this case, you're getting records that are outside of the overlap on both sides. An inner join is the only kind of join that limits the query to only the places where the 2 tables overlap, right? So there is a way to also get all the ones that are in neither, but we're not going to talk about that today. Don't use it very often. But this is basically, if you just want to find the ones that are in both tables, you would use this. If you wanted to find all the ones in the left table and get the value from the right table where it exists, you would use that one. If you wanted to get all of the values in the right table where they exist in the left table, you use this one. So it's just the opposite of this. And then this is give me everything, but just put nulls wherever the data doesn't overlap. All right. So actually, when you get this PDF, there's a link here to learnsql.com, and it has a great explanation of joins, better than I can do. There's a little video, super useful. But let's just go into these a little bit. So this is basically just a written version of what I just said. The only thing that I would add is something called a cross join. So a cross join is where you take 2 tables and you give every possible combination of those 2 tables. So like it's also called a Cartesian join because it's kind of like a Cartesian plot system where we take every possible like XY combination and we plot it out. A good example of this would be like language combinations. Let's say I have a list of languages and I want to find all the possible combinations of those languages, both directions, English to French, French to English, etc. If I do a cross join, I will get every single one of those combinations. So that's an example of when I might use a cross join. And the grammar for a join works like this. You have your select statement, whatever you're going to use there. And then we'll talk about this in a second, this little italics. From is your left table, generally. Like when you look at the on, that's where we see the left and the right. And then you say join to your other table, the right table, most of the times. Join users. So I'm going to join the shipping table. Remember we have that shipping table that had user IDs. And then we have a user table that has user IDs. And those user IDs are shared keys. And then we'll say on, right? And then we'll say on shipping.uid equals users.uid. Now, why do I have to do that? I have to do that because if I just say UID, the computer's going to get confused because both shipping and users have a column called UID. So I need to state which UID I'm talking about. So I say shipping UID on the left, users UID on the right, right? Now this join is an inner join. If I just type join, it'll give me an inner join of the 2. If I want to do another kind of join, I'm going to have to do something else. So let's take a look. All right, let's run it. Now, I don't have any nulls except for McSimmons because McSimmons has no name. But I might be missing some people, right? For example, I have record 101, 102, 103, 104, 105, 105, but I don't have record 106. Why 1006? Why is that? Well, that would be because if we look at the data here, 1006 doesn't exist, right? Also, 1008 doesn't exist over here, nor does 1007. So those records don't show up here. I am just doing an inner join. If we go back to our picture, I am doing this right here, only the place where the 2 tables intersect, right? So let's go back here. Let's say we get a little bit more specific and we say we want to do a left join, which is a left outer join. That means I'm going to get all of the records from shipping UID, right? Where those users are in the user database. And then I'm going to get all of the columns from here. And then at the end, I'm going to append the first name, last name. So I know who actually made these requests, right? Let's go ahead and run it. You'll see the data is different this time. So in this case, I have similar data, but then when I get to 1008 and 1007, I have nulls here. That's because they're not in the user database. So I still have the records before those records weren't included in my results, but I don't have a name for those people. So if I want to include all of the ones that are in the database and just fill in their names, then that's how I would do it, right? One thing to note here, you remember McSimmons had a null? Well, that's because McSimmons had a null in the user record. If I just say like, well, tell me all the records where there is no user, I might get confused if I did that on first name because McSimmons doesn't have a first name. So we just got to be careful when we're working with nulls like that. And how could we be careful? Well, one option would be to put in a where statement. Remember our handy dandy where filter? We could say where first name is not equal to, well, actually, this is the hard part. For null, you say is not null. You don't say it doesn't equal null. You say is not null. And then you might also say, let's say we actually only want users that are active. And active, I don't have to put users dot in this case. I mean, I did up here just to be clear, but I don't have to. I don't think. Let's find out. Some languages you do, some languages you don't. Active is true. Let's try it. Yep. So this is limited, even though we said get everything whether it exists in the right or not. One of the things that we've done, remember I mentioned that you could accidentally filter farther than you wanted. What happened to 1007? What happened to 1008? Where did they go? Remember our records here? We had orders from them. And we said we're doing a left join. We want all the stuff on the left, even if it's not in the right. Well, the problem is I filtered on the right. I filtered on my right table. So by putting a filter on my right table, I actually pretty much brought this back down to an inner join because I'm only going to get records that are in both because I'm filtering on both, right? So that's something you have to be watch out for. You could be like, well, I did everything I could. How come I'm missing all these records? It's probably because you filtered on something in the right table when you didn't mean to, okay? So if you're doing a left join, don't filter on the right table. You have to figure out another way to do it. Otherwise, you're just in an inner join, okay? Now, if I get rid of these and I say instead, tell me all of the orders where the number of packages is greater than 0. So the only one that we would probably get rid of here is this one. You'll see that all of those things that we wanted came back because we're filtering on the left side. So now all those null ones that don't have records in the right are back. My where statement didn't limit me. Turn this into an inner join. Now, on the opposite is true if I have a right join. So if I have a right join and say, show me where all the packages are greater than 0, it's actually going to like limit it because I'm filtering on that part, right? As opposed to finding just the ones that are in the right side. So just be aware of that. Your where statement can turn your left or your right join or even a full join into an inner join if you're not careful. And that's basically if you try to filter on stuff that is in your limiting table, then it will make it so it won't show the stuff that doesn't have a record in that table, if that makes sense. Again, let me know if that didn't make sense and I'll go over it more. But just know that you can break your joins by trying to filter on the side that doesn't have data. Okay, cross joins. Okay, cross join grammar is different than, one more other thing on this. I can have more ons, right? So let's say that our user table had a zip code field as well, the zip code of that user. So the home zip code, in fact. So show me all of the users that made a shipment from their home zip code. And I could say, so where UID and the users equals UID and the shipping zip code equals the user's home zip code. That's something I could do, and then it would find me just those ones. So the on can actually act like a filter. And just like where can cause problems with your join, using the wrong things in your on section can also cause you to have problems if you're not careful of how you use it. If you refer to stuff that you didn't mean to, it would automatically exclude things that don't have a value in that field. So for example, if I filter on something that has a null it's not going to get picked up unless I'm joining on nulls, right? So anyway, beware of that. Lastly is the cross join, right? That we're going to talk about today. The cross join grammar is a little bit different, where we take two tables and we cross join the other one, right? So I'm going to take a source locales table and a target locales table, and then I'm going to cross join them together. And what cross join does is instead of lining up on a particular field or one or more fields, it just finds all the different combinations it can find, right? So in this case, I'm going to do that, and then I'm limiting it to only source locales that are active, and only where the target locale and the source locale don't equal each other. I don't want EN, right? I want EN US to French for France. I don't want EN US to EN US, you know? So let's say that's what I'm going to do. Run it. So this gives us all the possible language combinations we could have. ENGB to ENUS, French to ENUS, Italian to ENUS, German to ENUS, ESCS to ENUS, French Canadian to ENUS, and then all the same thing to ENGB, French. You get the idea, right? So that's kind of what a cross join does. It allows you, it'll mix all of them together with any number of combinations. Now, if I had more than one, like more than one column, it would actually make even more combinations, right? So it would find all the combinations of all the many different columns and could be a big mess. So use cross join sparingly and when you need to. There was one other thing I wanted to talk about with joins, and that was that if you join something that has multiple records, okay, yeah, that's what it was. Okay, so let's look at this real quick, right? In this case, I have like only one record per user in here, right? So if I do a left join here, where this is my left table, the shipping table is my left table, and the user table is my right table, I'm still only going to have the same number of rows as I started with, right? But on the other hand, if I were to join the user table to the shipping table, I'm going to have more rows than I started out with. And let me show you what I mean. So let's say I'm going to do users is, we'll just do all from users, all of the columns. So again, if you want to reference a certain column in a certain table, or you either use its alias or the table name, dot the field or asterisk, users dot that, and then I want to do origin state. All right, and I don't have to put the table name in there because that same column doesn't exist in both tables, so it won't get confused. So this time, users is going to be my left, and shipping is going to be my right, and we're going to join on same thing, users. See, it's my left part of that equals part, UID equals shipping dot UID. Let's see what happens. Now, what you'll notice here is I have multiple 1005s. My user table only has one, but now I have multiple 1005s because your user 1005 has multiple records. So one of the dangerous things that can happen is you could accidentally get too many records. So for example, like if I was trying, if one of these had like a column that I was trying to sum and I didn't realize what I'd done here, I might have duplicates there, and I might be summing more things and counting things twice than I'd wanted, right? So for example, if I took this and I said, tell me the like count of users, right? So let's just try that right now. Count of UID of users. Let's just see what happens here. I'm not sure if MySQL will let me do this. It might get upset. Oh, count, yeah, users dot UID. It counts 6 users. Well, to be honest with you, Is there 6 users? Let's go back. How many distinct users are we talking about? Only 5. 1, 2, 3, 4, 5. And that's and it's double counting them because I have 2 records for Theologicus, right? But if I do distinct, this is where distinct comes in handy. I can kind of solve that. But the better way to solve that would be to find a way that I could either have 2 keys to make sure that I'm keying on only unique entries, or to rethink my join and make sure I'm not accidentally duplicating data I don't mean to duplicate. Now, you might mean to duplicate it sometimes, but most times you won't. All right. If you're done, if you're like, gosh, I'm an hour and a half in and I'm done, or I already went through all of this, okay, be done. But if you want some coolness, stick around for width, okay? We only have 2 slides here. I'm going to go over it real quick. And yeah, they look kind of scary, but they're super cool. All right, so width. Let's say you want to do a query on a query, right? So let's say you get all of this data about the shipping table, right? So you're looking at what is the sum of the total packages shipped by a certain person in each state that they shipped them in. And what was the average number of packages for that person state combination? What was the average cost, et cetera, et cetera. Now you want to use that data and query on it again, right? The cool thing is you don't have to like export it and put it in a table. You could do what's called a subquery where you could declare all of this as your from and then query it. But even better is, what if I can just pretend that I have a table? I'll just pretend this query is a table. That's what we do with width. Not every version of MySQL uses this. For example, MySQL 5.7 doesn't allow you to do this. Not every SQL language allows you to do this, but it is really cool when they do. So let's just get an example. Let's take this query and see what information it gives us. All right, so it gives us the user ID, the state, total number of packages sent by that person in that state, overall cost, average packages, average per state, average cost per state, average spend per package in that state, average cost per package in that state, right? And so for some of these users, like Mr. Theologicus, he's got multiple entries here because he ships stuff from both Colorado and North Dakota. So let's say that I want to find out, that's great, this is information, but let's say I want to aggregate that, right? That's where the with statement comes in. So if we look at that, it looks like this, where we first set up this fake table, and this fake table is right here. We stated fake table name, shipping stats by state, as, here's our query that we just did, right? And then we can query that. So you see, when I look at from, we have users, right? And then I'm joining to this fake table I created. Now, remember I told you that you could create an alias if you really felt like it got too long? You can do it here. I'm going to call it SSBS, right? So let's go ahead and do this now, just so you can see what it looks like. So I take my with statement, I throw it in. Has to go at the top. Can't go anywhere else. Has to go at the top, right? If I run this right now, nothing happens because there's no select statement. It's just kind of a prep thing. It runs that query first and stores it in memory. So in that way, just beware, it is super memory heavy to use a with statement. If you're going to be using it a lot, or if it's really huge, you probably want to just be careful and write it to a table somehow so that you don't have to like store it all in memory. All right, and then once I have the with statement, I have my select statement. Now let me explain the select statement because it's pretty nifty. I'm joining to the users table, right? So I'm going to have first name, last name. And since I'm actually going to like aggregate that this table up here where we got the user ID state combinations, I'm going to actually create a list of all of the states a person works in. So this is called group concat. So remember we talked about an array where it's like a dictionary or a subtable? That's not what I'm making here. What I'm making here is just a list, and it's a comma separated list. So I say, here's my field, the origin state, not from the original shipping table, but from this one here in this like mini table that we made, the shipping state, right? The origin shipping state as states. So I called it plural because there's going to be more than one now. Then I'm going to do the sum of the total packages from here, this total packages, right? I'm summing all all of the sums. So I'm summing the individual state sums. And that'll be my total packages. This is essentially as if I just summed them all together instead of breaking it out by state. The average of the total packages, so is the average in each state. So the difference is this, not the average number of packages they sent each time, but what was the average number of packages they sent in each state, because I'm aggregating on the user state data, not the overall data. What is the sum of their overall cost that they spent in all the states? What was the average cost that they spent in each state? What was the max average spend per package in each state? And then what was the max average cost per package in each state? So I'm going to left join to that mini table that I made, user IDs to the SSBS ID. And I can already see I'm making a mistake. And let's see if you can see what it is. I just showed it to you a second ago. Oh, no, I guess I didn't make that mistake. I thought I did. No, I thought maybe we were going to count Theolodicus twice, but I think he's fine. All right, so as you can see here, we have Noel McSimmons in California sent 0 packages, average packages, but he spent $155. So he must have just bought some like bubble wrap. That's a lot of bubble wrap. And then Cody McCodeface is null because Cody McCodeface didn't show up in our data here. Because guess what? There's no 1006. So he's a user, but he hasn't spent anything. Because remember, we did a left join. And then Jane Doe, she total packages was 225 packages. Average packages per state was 225. Total cost is 490. Average total cost is 490. Average max spend. So they're the same because only spent one place. Joe Schmo, same thing. John Smith, same thing. Now, John Doe or Theolodicus Doe is the only person who is different. So Theolodicus Doe had purchases in Colorado and North Dakota. And you can see I could probably make this better by having a comma space as my separator right here. And that way it would look a little bit neater than being jammed together like that. So average number of total packages was 120. Total cost was 1487 in all states. Average total cost was 743 in each state. Max spend per package between each state was 1233. Max average cost per package was 1233. So, yep, that's an example of how we did that. So we were able to first write a query, manipulate that data, and then join to that data first, or join to that data next. So hopefully that makes sense. But basically, what with allows you to do is to do these subqueries, manipulate the data, pretend it's a table, and then reference it later in your query. Yeah, that's it. Now, one thing to note, like, remember I said you can't use aggregates in a group by? This would be an example. Like, I can't use group by an aggregate, and I also can't say when of an aggregate. Remember that can only be something that's non-aggregated. So let's say I wanted to do that. I could actually put a when in here and reference something that was aggregated in my previous query. And so that's one example of why I might want to do that. Anyway, this was a game changer for me when I realized this. It is a bit more of an advanced topic. If you didn't understand it, don't worry about it. Keep digging into it. Keep thinking about it. But it is kind of like the next level, and it allows you to do really cool stuff. And we might talk about it one other time here, but it won't be on the test.